Alright, welcome to School of Chemistry. If it's your first time, make sure you click on the subscribe button. In this class, we'll be looking at relative molecular mass. And our intention is that by the end of the class, we should be able to explain what the relative molecular mass is and be able to calculate the relative molecular masses of substances. Now, what is relative molecular mass? Relative molecular mass or molecular formula is the sum of the atomic masses of the component elements of a molecule or a compound. For example, given a molecule Y2, the relative molecular mass will be what? The sum of the atoms of the molecule. And in Y2, we have two atoms there. That is why 2 is there. The 2 there is the atomicity. Remember, we discussed that when we were looking at molecules. The atomicity of Y there is 2. That means there are 2 atoms of Y. So I'm going to look for the atomic mass of Y. Add it 2 times, and that will give you the atomic mass of Y. And for a compound like A2Y3, we have to sum up all their component atoms. Like in A2Y3, we have 2 atoms of A, 3 atoms of Y. That means the molecular formula is going to be the atomic mass of A is there 2 times, and the atomic mass of Y 3 times. That is, you add the atomic mass of A multiplied by 2 and the atomic mass of Y multiplied by 3. This is the ratio in which they are present. That is what will make up the molecular mass of the compound. For a compound like A, B, D, we are saying that the molecular formula is simply A plus B plus D, because these are the component elements. All you need to do is just to sum them up. All right, let's look at how we calculate the molecular formula of compounds, of known compounds. For example, if you are to calculate the molecular formula of H2O, the data you will need to do this basically is your relative atomic mass, which is often in exam situation is provided, or you get them from a periodic table. So how do you go about this? H2O is made up of, from the formula, 2 atoms of hydrogen plus 1 atom of oxygen. From our periodic table, the atomic mass of hydrogen is 1 and the atomic mass of oxygen is 16. So we're going to have 2 plus 16, and this will be equals to 16. This will be equals to 18 grams per mole. 18 grams per mole, and that will give you the relative atomic mass of the compound H2O. What did we do? We simply added the component elements together. Now, let's look for the relative atomic mass of the compound CaCO3. Let's calculate the formula. This will be equals to Ca plus C plus 3 oxygen. The atomic mass for Ca is 40. The atomic mass for carbon is 12. The atomic mass for oxygen is 16. So this will be 40 plus 12 plus 48. When you multiply 3 by, what did I do here? Supposed to replace it. Supposed to be 3 into 16. 3 times 16 will give you 48. And if you sum this together, supposed to get 100 grams per mole. The relative molecular formula is expressed in grams per mole. So now quickly do this for us. Calculate the relative molecular formula of for NaOH. Do it quickly. The relative molecular formula for NaOH. That is sodium hydroxide. What did you get? If you do it correctly, you're supposed to do 1 atom of sodium plus 1 atom of oxygen plus 1 atom of hydrogen. This is supposed to give you 23 plus 16 plus 1. And this is going to be 40 grams per mole. So that is it about how to calculate the relative molecular mass. We say the relative molecular mass or the molecular formula is the sum of the atomic masses of the component elements of a molecule or compound. Well, for that to see how to calculate or to derive these formulas from given atom, basically the details you need to get your relative molecular formula is the atomic masses of elements from the periodic table, which are oftentimes provided during exam situations. So that is it. Welcome to the channel. Do not forget to subscribe.